This is chapter 17, set C, problem 2. Tells us that we have 100 draws at random with replacement from our box that has the numbers 1, 3, 3, and 9. So A, this isn't something that we really have a procedure to do or I expect to memorize, it's just more of a logic thing. It says, how big can your sum be? Well, if you think about it, we're drawing 100 times. If, by chance, I happen to get the biggest number there, which is a 9, if I happen to get the 9 100 times, so if we get 9 100 times, that would be 900. That's going to be the biggest we could possibly get. So normally, like, we're going to get some 1s, we're going to get some 3s, we'd get some 9s, and we'd get a mix of numbers. But if for some really weird reason we happen to draw the 9 100 times, that would be the biggest we could possibly get, because 9 is the biggest number, we'd get 900. If you want to look at how small could your sum be, well, getting 9s, that's not going to make it very small. 3s will kind of be in the middle. If I happen to get 1s every single time, that would be the absolute smallest I could get. So if we get a 1 100 times, then the smallest sum you could possibly get would be 100. Now in part B tells us that we want to find the chance that the sum is between 370 to 430. So the sum was somewhere in there. Now for these problems, to save you time, I'm giving you guys, sometimes I'll have you find the average of the box because you can do that a little bit faster, but I always give you the SC of the box at least. This time I give you the average of the box and SC of the box. And now we have to find the chance for the sum. Now anytime you see that chance, you're looking for the chance for the sum, you're going to say, okay, first steps are first find the average and SC of the box. Next steps are find the expected value of the sum, because we're looking for stuff for the sum, so we want expected value for the sum. Now expected value for sum, we know, is always going to be our number of draws times the average of the box. So we're drawing, we said 100 draws, so 100 times the average of the box, which I told you is 4, so that would be 400. And the standard error for the sum is going to be equal to the square root of your number of draws times the SC of the box. So we're going to do square root of 100 draws. Now notice this square root only includes the 100, so make sure you don't put anything else inside the square root, times the SC of the box, which I told you is 3, and that should give you 30. So first step is average and SC of the box. Then you find expected value and standard error. Because you know to find a chance using the normal curve, you're going to have to get to a z-value eventually. And we know that our z-value is always going to be equal to the sum we're interested in minus the expected value for the sums over the standard error for the sums. So the sum we're interested in, notice we have two different sums we're interested in. So let's split up and we're going to find a z-value for each one. Okay. So for my first one, let's do 370. So 370 minus our expected value of 400 over the standard error of 30, which gives me -1. When you put it in your calculator, remember you need to put parentheses around everything in the top. For my second z-value, again, we're going to do the same thing. Sum minus expected value of sum over standard error of the sum. So our second number we're interested in is 430 minus expected value of 400 over our standard error of 30 gives me +1. Now, you might remember that about using the empirical rule or the 68, 95, 97 rule, we know that, sorry, not 97, 99.7 rule, we know that about 68% of our data should be within -1 to +1 standard errors of our expected value. So because z goes from -1 and 1, you could just say 68% here. But I don't expect most of you to remember that or to think about it this way. So instead, we draw a curve, because we should always be drawing a curve every time we're looking for a chance. So here's z equals -1. Here's z equals +1. And we want, notice up here, we wanted our numbers to be between 370 to 430. So we want to be in between these two values. So I pull up my normal table. And I look for z equals -1. So we're right here with an area of 15.87. But notice that will be the area to the left of -1. So coming back, we have 15.87%. But that's only from here, from -1 over. That's not actually the area I want. Well, what if I look up z equals +1? So z equals +1 gives me 84.13. So from +1 all the way over was 84.13%. So what we want is we want this area in the middle. We want the area in the middle. Well, how are we going to find that? Well, we say if the area from z equals 1 all the way to the left is 84.13, and from -1 to the left is 15.7, but we wanted the area in between. So what are we going to do? We're going to subtract out that 15.87. We don't want that in there. So we'll do the 84.13% minus 15.87%, which gives me 68.26%. Now you'll find the textbook often rounds these to the nearest percentage. You can if you want to. I would just leave it as 68.26%. So that means when we draw out of the box 100 times, sometimes we're going to get 1s, we'll get some 3s, we'll get some 9s, and at the end we add it up, and there's about a 68% chance that the sum we get when we added those up will be between 370 and 430.